Hi everyone, this is yours truly, Lady Manuel, coming back with part 3 so that I can go more in depth with number 6. Here, and we already got the table part, the pink. I have this here. I want to sketch, or I'm just, yes, I better use the pencil to sketch the pink, connect the pink point, which is the parent function. The pink is the parent function. Okay, here we go. That's our pink. I would go ahead and highlight it so we can make sure that we see. Oh, man, why am I not perfect? So that's the pink graph for our parent function. Here for the green one, let me finish plotting those points here. I got 0, 3, the vertex there. So here I got -1, 4, -1, 4, and also it'll be 1, 4. Then we have here, don't ask me why I said, yes, 1, 4. Then we have 2, 7. So we have 2, 7, 2, go up to 7. Then we have -2, 7. Then we have 3, 12. 3, 12. Trying to make sure I stayed on 3. Okay. Then -3, 12. Okay. The pink don't really go through those points, just FYI. It's that high I drew. So make sure you sketch yours better than how I have mine sketched. So here we go. Here is that the highlighter I use, so it makes it seem like the pink is going through it, but it's not. It's that highlighter. So make sure you do yours much better than your lovely teacher here. So try to sketch so that you can see it. Okay, here we go. So now when you look at the graph, you see your little nice information here. You see the pink, the parent functions, and you see the green. What do you notice about it? What I notice is that from the pink, it said 0, 0. The green went up 3. So it was translated up 3. It's almost the same, but it was just pushed up. It's like a translation up by 3 units. That's what I noticed about that graph. That's the only thing that changed. So here, down here, it told us for f of x, it said what is the vertex? So for our parent function, that vertex is at 0, 0. That's the point that it's at. Okay. For the x squared plus 3, the green one, the vertex is at 0, 3. The axis of symmetry is for the pink one is x equals 0. It's the x value of the vertex, that is the axis of symmetry. As you can notice here, the axis of symmetry is also the x value of the vertex. So that means that right here, this is the line of symmetry. The parabola is symmetrical. I can fold on this line of symmetry, meaning it's the axis of symmetry. And that is your y-axis, meaning that it's x equals 0. It's a vertical line. Now with the domain and range. Now guys, when you're dealing with quadratic function and it's open upward and it has an arrow and they're connected, then your domain will be all real numbers. So here, it'll be all real numbers. All real numbers. You know what? I'm just going to write it like this. This means I'm writing with this notation. X is the element of all real number. X is the element of all real numbers. You can write out all real numbers, or you could write it with the notation using the symbols. Okay. Oh, I'm so sorry if you didn't see this. Okay. So here's the vertex. The domain is x is element of all real number. The axis of symmetry, x equals 0, x equals 0. Okay. And now the range is the y. If you notice, and you probably say, why is the domain all real numbers? Because it doesn't matter where I go on this x-axis, I can go up to get to that graph because it keeps going on forever and ever. So I can go anywhere on the x-axis and go up and touch the graph. It doesn't matter where at. Now, whereas the y value, it's not down here. So the y starts here at the vertex. So you use your vertex to be like, what is the y value? So in this case, it's going to be y. And since it's a vertex, it's going to be y, it's going to be greater than or equals to when it's open upward. It's going to be y is greater than or equals to when it's open upward. If it was open downward, it'll be y is less than or equals to, because the y value is getting greater, it's getting larger, it's increasing. Okay? Therefore, it's going to be y is greater than or equals to whatever the y value is for your vertex. Okay? So here my vertex y value is 0, so my range is y is greater than or equals to 0. Here, my vertex y value is 3, so y is greater than or equals to 3. Notice here, this is y, 0 is going up, up. So I can go anywhere on the y-axis and get to those graphs. Anywhere from 0 on up, I can go anywhere. Okay? Here, it'll be from 3 on up. From 3 on up, I can go left or right, and I can get to that graph. So that's that for this video, part 3. I just want you to make sure you understand this most definitely. And also, yeah, I said this is it. But part 6, number 6 at least, you're doing the same thing here for number 7. Same concept. Same concept. Okay? And then you're comparing, number 8, you're going to compare this information, g of x. I mean, here is h of x. You're going to compare h of x to your g of x. So your green